Ever wondered how to manage your applications running on hundreds or even thousands of servers? Welcome to the world of Kubernetes. In this vast digital universe where applications are deployed across a myriad of servers, Kubernetes emerges as a powerful galactic cruiser. It's a potent tool that simplifies the complex task of managing containerized applications. Imagine trying to manually control each star in a galaxy. Daunting, right? That's where Kubernetes comes in, turning this Herculean task into a walk in the park. Now let's briefly touch on two essential concepts within Kubernetes: deployment and statefulset. These are like the twin engines powering our cruiser, each with its unique role. Deployment ensures a specified number of pods are always up and running, while statefulset manages the deployment and scaling of a set of pods, maintaining a sticky, unique identity for each of them. Stay tuned as we delve deeper into the workings of deployment and statefulset in Kubernetes. Imagine being able to manage, update, and scale your applications with ease. That's where Kubernetes deployments come in. Kubernetes deployments are like the conductors of an orchestra, ensuring all the instruments, or in this case containers, are playing in harmony. They are a high-level concept managing the desired state of an application, which could be as simple as ensuring a specific number of identical pods are running at any given moment. But they do more than just keeping an eye on the quantity. Deployments also handle updates to your applications. When you push out a new version of your app, deployments ensure a smooth transition from the old version to the new with zero downtime, like a magician performing a flawless sleight of hand trick. How does it pull off this magic? The secret lies in the underlying replica sets. Like faithful minions, replica sets ensure that a specified number of identical pods are running at all times. If a pod goes down, the replica set spins up a new one. If there are too many pods, it removes the extras. But the real magic happens when updating the application. The deployment creates a new replica set and increases the count of replicas while the old count goes down. Voila, a zero downtime update. Deployments also allow you to scale your applications. Need to handle a surge in traffic? No problem. Increase the number of replicas and Kubernetes handles the rest. It's like having an elastic band that stretches according to your needs. And there's more. With deployments, you can pause, resume, and roll back updates, giving you an incredible amount of control over your application's lifecycle. It's like having a time machine at your fingertips. With deployments, managing your applications on Kubernetes becomes a breeze. But what if your application requires stable, unique network identifiers and stable storage? Enter statefulsets. In the world of distributed systems, state matters. That's where Kubernetes statefulsets come into play. Let's put it this way. Imagine you're at a bustling party with 100 guests. It's a great time, but there's a problem. You don't remember everyone's names. That's a bit like how Kubernetes manages pods in a deployment. It knows the pods are there, but it doesn't keep track of them individually. It's a bit of a free-for-all. Now, let's say you're at a smaller gathering with just a few close friends. You know everyone's names, and if one of them had to leave, you'd definitely notice. That's what a statefulset is like in Kubernetes. It's a way of managing pods where each one has a unique, persistent identity. Statefulsets are crucial for applications that require stable network identifiers, stable storage, and ordered, graceful deployment and scaling. They ensure that the pods are created sequentially, in order from 0 to n. Each pod has a unique ordinal index and a stable network identity. This provides a predictable and reliable way to address and interact with individual pods. Let's delve a little deeper into the idea of stable storage. The statefulset ties each pod to its storage, or persistent volume, which remains even if the pod is rescheduled. This means that the data associated with a pod in a statefulset is persistent and safe, even if the pod itself goes down. Now you might be asking, why does all of this matter? Well, many applications like databases require a certain level of predictability and stability to function properly. They need to know where their data is, and they need to know that it's safe. That's what statefulsets provide. They give these applications a predictable and stable environment to operate. In conclusion, statefulsets in Kubernetes are all about providing order in the chaos of distributed systems. They give each pod a unique identity, and they ensure that each pod's storage is safe and stable. Stateful sets give your applications the stability they need to run smoothly in a distributed environment. But how do these concepts work together? Deployments and stateful sets, two powerful tools in your Kubernetes toolkit. But when should you use each? Let's dive into the details. Think of deployments as your go-to tool for managing stateless applications. Stateless applications, as the name suggests, do not depend on any specific state for their operation. This makes them perfect for deployments, since Kubernetes can easily create, delete, or replace pods without affecting the functioning of the application. Imagine your typical web server. It doesn't care which specific requests it has served before. It treats each request as a new one. That's a stateless application, and deployments handle these with ease. Now, let's turn our attention to stateful sets. These are designed for applications that require some form of persistent state. Think of a database system where data is continuously updated and needs to be stored in a certain order. In such cases, the identity of each pod becomes important. Stateful sets ensure that each pod has a unique and stable network identity, allowing the pods to die and respawn without losing their place in the system. They also provide guarantees about the ordering and uniqueness of pods, which are essential for maintaining the state of the application. So, how do you choose between deployments and stateful sets? Well, it depends on the nature of your application. If your application doesn't require any persistent state and can handle pod replacements and rescheduling, deployments are the way to go. However, if your application needs a stable network identity and persistent storage, you should opt for stateful sets. Remember, both deployments and stateful sets are powerful tools, but their strength lies in their suitability for different types of applications. It's like choosing between a hammer and a screwdriver. Both are useful, but you wouldn't use a hammer to drive in a screw, would you? Whether you need to manage stateless applications with deployments or stateful applications with stateful sets, Kubernetes has got you covered. The choice ultimately depends on your application's needs, and with Kubernetes, you have the flexibility to choose the right tool for the job. Now that we've explored the world of Kubernetes deployments and stateful sets, let's recap what we've learned. Deployments, the heart of rolling updates, provide a declarative way of updating applications. They ensure zero downtime and allow for easy rollback in case of failure. On the other hand, stateful sets are the go-to when you need stable network identities, stable persistent storage, and ordered, graceful deployment and scaling. They're essential for applications that require one or more of these. At their core, both are about managing your applications, but they serve different purposes. Deployments are ideal for stateless applications that can be replaced, replicated, and scaled easily. Stateful sets, however, are perfect for stateful applications where the identity and state of each replica must be preserved. Kubernetes deployments and stateful sets, two tools that make managing your application